done an unboxing video before. That's box one, I guess. Parts, square stock, heavy stuff. I don't see any labels. Nothing appears to be numbered unless there's something inside there. This one's been bounced around a little bit. Some nicks and stuff there that have been painted over. Not terrible. That's what we got. Okay, onto the box two. Something in the back of my brain's telling me there's no instructions. You had to watch them online or something. This stuff's labeled though. Torch firing hardware. Ooh, Scotch locks. Evil. These are our motors. Aha! Welcome. Everything in here is going to give you cancer, and my children will, I don't know, be really good at cutting metal. Caps. It's for all those, all the 2x2 tubing. That looks important. Well, they tried to put the stickers on straight. I was a little drunk that day. These are the rollers. All that square tubing goes on. Very cool. Yeah, they got the little them on here. I always scoff at these unboxing videos, especially when it's for like a TV. Like, what do you think was going to be in there? And then I watched a bunch of them like this for different plasma tables, and I was like, oh wow, I can see in the field. Box 3 of 3. These are the pans, obviously. I didn't realize there were two. Man, that must have been that guy's first day with that staple machine. Look at that. There it is, the pile. Pick up some stuff. I'm gonna watch the instructional videos for a minute. Find a few things. Okay, step one. Bottom up, I guess. Got these feet. Got these inserts. Basically, hit in with hammer. Okay, let me get the nuts. Bag 14, bolts 4-1. Going to this thing. Take these. Bolts go at the top. Foot goes at the bottom. These guys, you know, just tap, tap, tap. And that's it. That's in. Take your bolt. Put it in the foot. 2 nuts. You tighten this one down. Holds that foot on there. This other one screws in here. Then you can adjust your height. And wherever you get it, you tighten up this other nut. That'll hold it there. Ta-da. Woo! Step one of many. So the two that are tattooed, these guys, these are identical. So what we got here is you put the two that are tattooed on the bottom, facing the tattoo out. You can look at the picture. It does make sense after a minute. Under here, this spacer goes up in that hole. That corresponds to that hole. So when we put a bolt down through here, that all sticks through. Boom, boom. The leg goes here. So just in this front corner, large hole on the top, and then on the inside of that towards the middle, there's a larger hole. That has to go on the inside, if that makes any sense. It's the same thing over here. You got a large hole on the top. There's a large hole towards the inside on the inside side. It's larger than the outside side. That's how you know you got it in the right spot. Okay. You get all this set, get these kinda tight. Then you got a square corner to corner. And then you gotta measure the insides of these. Make sure they're the same. You can measure the outside, inside, it doesn't matter. Just make sure it's the same at each end. Once you got it all square, carefully walk around and tighten the whole thing. Okay, the two legs that have the holes in them, the small holes for the electronics, I guess go on the Crossfire Pro part. Here you go. That corner and that corner. You put two spacers in, one through the leg, one through the frame, bolt. The pictures show that they always go outside to in. So bolt goes this way, bolt goes this way. And then the other two that don't have the holes go out here in the other corners. Now we're on to the Y-axis bearing block carriages. Alright, next step. Got bag 19, bag 15, bag 7, bag 16. Got these two things. And we got these four. We got a really cool picture. The only thing that it says is that you bolt these on. Make sure that your orientation for your adjusters is on the top and pointing the same direction as that doohickey. So, set screw goes on there. Those are only on there to help with that. Neat. Alright, it looks like you get these on there, just make them finger tight, because these need to float. There's a lot of adjustment there in addition to this. So these need to float before you clamp them down, which I'm assuming is whatever the next step is. You got to get these oriented. Alright, what do we got? Next step. bag 20, bag 3, bag 13, basically all the 3/8 hardware. These plates are all wrapped together. Should be 8 of those, and then these 2 things that we just built. And then you need the 2 stainless rails. Alright, so it looks like from the photo that they gave, you gotta make sure that the large hole that's on this thing is at the proper end. These 2 smaller holes go on the bottom. So this one's the left-hand side. This large hole goes down there. And then on the other side, it's the opposite. That large hole goes at the right-hand side. I don't think it really matters. They're both the same. You just got to make sure you got them the right way. Okay, what I did, I got these on here loose. You slide this on, then you can pick this whole assembly up, put it in here and do 1 bolt at a time. Keep these loose so you can get them in there. Okay, we got these on. It's actually really cool. Thing says to make sure you tighten these bottom ones but not the top ones. So, don't know why. I'm assuming you can move these just a little bit in there. You also need to be able to put some bolts through here. So if you tighten these up and they're not in the right spot, I'm guessing it won't work. I'm going to leave all this finger tight for now. Okay, I think I got all of the stuff. Got bag 7, 16-1, 8, and 7-1. Wrapped up, they had some of this stuff. There's 2, I don't think you need that. This is the Z-axis. Fun. Mount for it. And there was a separate bag in there that had these black powder coated brackets. So it's just like doing Legos when you were a kid. Okay. So that looks, here's what I didn't use out of that. Pretty straightforward, to be honest. Just like Legos. So, here, this got crushed a wee bit. Hopefully, that doesn't impact it much. There. Fixed it. I didn't know which one to use. Alright, this part's confusing. Get all these out of the package. So you line up all these red pieces. You'll notice all of them have the same spacing between the threaded holes, except for this one. This spacing's larger. This is the one that you use on this step. So when you orient this thing, the pass-through holes go on the top. This hole goes that way, motor up. Best way I can describe it. These 2 holes here have the wider spacing, so they correspond to this motor mount. So I would use the shorter one and this one on there. Seems right. Just, you know, the 3rd time I put it on, figured I'd share. Next step is simply you just put that part we just made on there. Yeah, how hard could that be? Don't forget the spacers. goes bag 2, bag 6, bag 16, and whatever the nuts and washers for the 3/8 stuff, whatever you have left. Ooh. Not tighten these bolts. Okay, so finger tight on all this stuff. Now we're doing the Y-axis adjustment. Ooh. Alright, they're having you adjust the bearings now. So the way that I'm doing that, pretty much what they say. Get this, you know, just barely tight, because you need that to float. So don't have it tight, but don't have it falling off. This set screw on the top moves that. You can see when this moves right now on each side of there, there's only one wheel turning. So we're just gonna slowly tighten that until we get at least 3 of them moving. Basically just messing around with this till that barely slips. It's got resistance, but it will turn. That's what I'm calling good. It's rolling. Now you just do that on every single one. Okay, and then once you get that set, you got to tighten up these. So we didn't tighten these before. So now what it's saying is slide this all the way back so that everything's touching on both sides. Then you tighten up these 3, then you tighten up these 4, and then slide it that way. Do the same thing at that end, tightening up those. So basically it's get this thing anchored that way and tighten up everything that's left. So this will probably be the part I like least about this table, is the fact that that pan's in 2 parts and you silicone it together. Like, it won't last forever, but 12, 25, and 27 are your drain plugs. So yeah, we're gonna put that on first. And there's another thing. These are 11/30 seconds. So make sure you got one of them. That's about it for today. Pretty happy with that. So far the only thing I'm not digging is this 2-piece pan, which, I mean, I'm sure it'll work. If it doesn't, we'll just TIG that together and be done with it. But it's just, I mean, I don't know what your cost saving was making this in 2 pieces so you could ship it in a smaller box versus all this extra stuff and this extra welding. You could have had 1 drain, and don't know about that, but it'll work. And if it doesn't, everything else, just gotta fix it. Next step, put in the slats. That'd be the easiest step of this whole thing. Okay, the next part, tramming the Z-axis slide. So pretty sure that means this thing. And they give you a nice little video to watch about it, so I'm gonna do that. Okay, pretty simple. Watch the video. There's set screws. Set screws in here. Push these bearings in. You're locking this thing in perpendicular to your table. Assuming you're gonna have to check that a lot. Okay, we need the Y-axis lead screw bearing mounts. So you gotta get these bearings in here. Okay. Well, the instructions said you might have to press them in with a clamp, but you're good. Okay. Yeah, but keep that bearing from falling out. Alright, put in the bearing. Secure Y-axis lead screw bearing mount to the left-hand Y-axis rail using the 2 bag 7 socket head cap screws and hand tighten only. I'm gonna believe that you put one here and one over there because each one needs a motor mount, and these are gonna have the motor mounted to it. And that's gonna happen back there, as far as I can tell from the photo. These are the lead nuts. Wow. Look how long those last. We're basically putting this in down here on this little bracket. And then we're going to put one on here for the X, one on the other side for the other Y. It goes this way underneath the stainless line. Yep. Oh boy. Putting in the lead screws. We got 9, we got 2 of these, we got bag 9, bag 17. Okay, so these lead screws, one end has nothing on it, the other end is tapped. The tapped end goes out here towards the rounded face one. It says pull back on that spring, initiate this thing threading in. Probably want to get both of these started at the same time, so then you can slide this back and get these ends in here, because once you put that nut and stuff in there, it's not moving. Okay, these are pretty straightforward. 4 bolts that hold them in. Just make sure you put that coupler on first. So when you slide all this in there, you get the coupler on the shaft, bolt it up, tighten these 2 up, clamped on there. Same thing on the X-axis. So I haven't clamped these down yet, so pretty simple. It is freezing today. Got the fire going. Guess I should have been numbering these. We're up to 13. Bag 23, you need 24 of these, so make sure you got bag 23, not 24. Which isn't hard to do because 24 only has 4 items in it, but we're putting the gussets on the legs. There's no pre-drills, no nothing, so you gotta get these perfect all on your own. this is what I do whenever I need to line something up. So this gusset, you want it flush with this surface. So usually I use a piece of metal, but I didn't want to mark it up given that this is all powder coated. So I just clamped a board on here, and then I clamped this to this board. So I know that the face of this is flush with this leg, because this board's clamped to this leg. It's flush. And up here, you can see that gap. I just have this clamp on here, keeping that gap and everything 90 in quotes. So now I just, you know, use those self-tapping screws, screw it together. I'm not gonna get it perfect, but we get it pretty close. Which, it's just a leg. That's how you know you made it. Pro. And there's a good shot. There we go. There's a bunch of stuff you don't want to. Ensure installation of replaceable relay. That is not installed. So in the directions it says that there's a relay that goes here. It also shows another board over here, but oh, it's not missing. It's in here. So it said make sure that you've got this relay situated properly. I looked all over and I couldn't find it. It's right there. It fell out. Yeah, look at that guy. So this thing gets mounted over there on that leg. And there's an isolator that goes behind it. Just goes on there. Not bad. Okay, so the next steps on the normal installation are just running cords, putting in their little clamps, stuff like that. I am going to put on the LSTHC, which is just height controller. There is a lot to this. So I think I got it figured out. This little board goes on to that board. And just push the pins in, la-di-da. Life should be good. According to that, everything automatically turns on when you hook it up because it's pre-programmed, and when it hooks up it knows. La la la. This thing, if you have a plasma cutter that already has a DIV output, basically if you have a plasma cutter that has a CNC hookup in the back of it, you just hook that cable into this DIV input and then you use the DIV output. That's that. If you do not have a CNC hookup on your plasma cutter, it's just a plain Jane plasma cutter, which I accidentally bought. Okay, you need to take apart your plasma cutter and you need to get the raw voltage. Basically, you're hooking into the wire that sends the main positive out. Well, plasma works the opposite, so your ground clamp is actually the positive. So you need to hook to where your ground clamp hooks up, and you need to hook to where the torch hooks up. That's your raw voltage. So that's what these are for. and these plug into this, and this thing has a thing in it that drops it down 50 to 1, I think, or something like that. Basically, you need a thing that communicates to that controller what the voltage you're getting out of your torch through your material is. Because if the torch is too far away or too close, that changes. So the Hight controller adjusts to maintain a constant voltage while you're cutting. So if you're cutting something that's at an angle and it's getting close, it will notice that the voltage is dropping and it will raise the head, lifting the cutter up to maintain a constant voltage as it's cutting across an incline. I'm sure that made no sense. You'll have to read the instructions 20 times like I did. So I am going to put this little guy in here and then close this case up, because like I said, I really don't want to catch this on something and ruin it. But in here there's rails, and there's a little 13 right there. It says D13, and on this board down in the corner here it says D13. That's how you know it's oriented properly. That's the best that I got. So I'm gonna put this thing in there, and then I'm gonna put this cover on because it makes me nervous. I have to say, one of the inputs I would highly recommend to anyone is build this on one of these tables or something similar, so that it's up off the ground. I know it's not perfectly level, but it's close enough. It just lets the feet dangle. So when you're putting on all those gusset plates, you can get everything square before you put it down. I think it was a tremendous help for me. I didn't do it on purpose. It just, that's how I did it, and it seemed to work very well. So highly recommend building one on these tables. When you put that thing in there, it pushes all the way in. Those pins go all the way into that, and you're gonna feel like you're breaking the board, which I hope I didn't, but just keep pushing. Now we're gonna get that cover on before something really bad happens. Ta-da! I'm gonna be fancy, put all these things in. Okay, we got through all these boxes, all the parts that are left. So what we've got, this is everything to do with Hight controller. I need to take apart the plasma cutter, hook some stuff up to that. This is the Z-axis controller. So this gets hooked to this, run up with this cord down to the machine. Power cord for the box, and then this is the USB. And this, torch firing hardware. Another thing I need to dig into the plasma cutter for. So this is going to trick it into thinking you pulled the trigger. And then this guy measures the voltage coming off that for the Hight controller. How hard could it be? Okay, got those plugged in. Said it didn't matter which way you plugged them in, it would figure it out. Temporary, remember? And then over here, it plugs into the only one that it can plug in, the IHS. It's just like putting a computer together. It looks complicated, but you can't plug it in wrong. The next steps are dig out the plasma cutter and, you know, sabotage that, which I'm not really looking forward to. I don't like blatantly voiding warranties, but you don't make any money unless you do, I guess. So I'm gonna go get a laptop. We're gonna hook all this stuff up, and we're gonna see if this thing moves. It turned on and made a clunk. I don't know More things are making noise. It says it connected. I'm about to hit a button that should make all this move. Okay. Look at that. Ooh. What happened? Come over here. I can jog. At least you can hook everything up and hit these buttons over here on the right, and that'll tell you if things are actually gonna work, which thankfully in mine they did. Buttons are even doing the proper thing. How about that? Might be the coldest operating plasma table. It's 46 in here. Okay. Got a Powermax 45 XP. I did not get the one with the CNC hookup. It's an option. I can get it. I can hook it all up. I didn't know that when I bought it. I kind of got it in a bit of a panic because I needed one. It was COVID. You couldn't get them anywhere. This one popped up and it had a 50-foot cable on it, which we use this thing all the time, and I use it on construction sites. It works great for demo. If you're getting one, get that 50-foot cable because, man, it's all tangled up right there. It is worth it tenfold. So I can't just plug and play this thing. We have to put it all together. These are the leads that go to the voltage sensing of the torch. That's how much power the torch itself is using. This cable is for the trigger override. So we can use the torch head that's on the regular handheld unit that comes with this, but we need to trick the plasma cutter into thinking that we pulled the trigger. So that's what this cord's for. It hooks to the machine. We're gonna run it in here, hook it up to the wires that usually are controlled by that trigger. These are going on there. Luckily, there's a very nice write-up that you can find on the Langmuir Systems site, and it shows you how to do this on one of their Razor machines, which is similar to this, good enough. I'll do it on here so you can see what happens. There's also a link at some point in the assembly that shows you exactly how to hook this up on the Powermax, and that comes from Hypertherm. That's just a link right to them. So we're not really hacking into anything with that. This, bit of a hack. They want you to use these Scotch locks. I hate Scotch locks. Every time I see one of these things, they're bad. They corrode. It's just, they cut the wire. It just never, ever works out. Personally, I hate Scotch locks. So we're not going to use one of those. Unless I absolutely have to in here. I don't know what it's going to look like, but essentially in there's a ton of pins. We just need to find the 2 pins that this is going to override. So it's not too bad. Screwdriver. There's 4 screws. You can spread this apart. The handle comes off. Then you should be able to slide this cover off. And then once we get in there, I'll scratch my head for a minute and try to figure out what to do. Mind their torque's on the bottom. Oh, it's 25 torque, right. Torque 15 by 4 inch. I guess it's 15. You need to get that actually out of there to get that apart, okay? So, get these pins out. Well, in case you ever wondered what the inside of a Hypertherm looked like, complicated. Well, yes and no. Connect the positive lead to the positive threaded insert J22. Oh, there we go. Okay. It's under here. Raw arc voltage. Look at that. Tells you right there. So there's a positive here, negative here. How about that? So that's what we need for these guys. Need to route these through the back over to here. Boop boop. Cool. Use one of the screws included with the kit to tighten. Great. Well, nope, no screws. We'll dig around the good stuff pile. I'm sure there's something. These are probably metric. So here's one of the dilemmas. The orange and purple wires are the two on the torch and in the machine. When you pull the trigger on the torch is a switch. So that connects the orange and the purple wires. That tells the machine to turn on, you know, blow holes in metal. Where this thing plugs in, back here, a little wire. Oh, I'm sure you can't see. This thing plugs in back here. This is the group of wires that goes in to this plug with all these pins. It's the same colors in here. There's an orange and a purple. And this wire runs around the other side, is right here. Oh, once again, probably hard to see. So you can trace that, you just tug on it, whatever, you can see it. What I'm getting at is, there's a lot of slack here. So if you were to take the orange and the purple wire here, and you touch them together, this thing would just go. Because with the torch connected, when you pull that trigger, it's just a switch. And that switch connects those two wires. So if you cut those two wires and put them together, this will go. So the Langmuir system uses this. It uses its own switch. You're supposed to splice these in to the orange and the purple wires, making the system act as the switch instead of the torch. So instead of you pulling that trigger, the system pulls the trigger, meaning it just puts those two wires together. So the real question is, do I splice it together here in the machine, somewhere on this wire, where I'd have a lot of room and you can just run it out the back? Or do I do it here on the plug of the torch? Because the same wires are here, they connect to the same spot. I could do it right here and drill a hole through this cover. And then that way, I wouldn't be cutting or splicing anything in the machine, which I guarantee you voids the warranty. I'm not worried about this other one that I need to hook up for the voltage sense, because that has points on the board. I'm just screwing a peg in. That's supposed to be there. You're getting into cutting factory wires in here. I know they're factory wires in this torch handle, but great, I voided the warranty on the torch handle. That's a lot cheaper than buying a new machine when something messes up and they won't fix it. I've already had an issue with the switch on this. It's a little better now, but like it's a decent push to get that on. But to shut it off, I mean, if you look at that wrong, it just turns off. And it worked okay for like a week, and then there was a day you'd push it and it's off, push it and it's off. I mean, you could lay a hair on here and it'll turn off. So they took it in, and of course they said, yeah, it's real touchy, but it's like, well, it's bad. Can you just give me a new switch? And like, well, it works. We can't give you a new switch. I'm like, yeah, it works right now, but you're telling me that that 1/10 of a pound I have to put on that thing to shut that off isn't worth a new switch? Like, come on. So that's the issue I've had. It wasted a ton of my time, and I vowed I would never ever send this thing back in on warranty just because of what a pain in the butt it was. But if this circuit board fries for some reason, or who knows what, they're gonna open it up, see that, and say, well, we got you now. So I've decided I'm gonna do it in the case, run the wires out the back with these other ones. Let's void a warranty. We're gonna go through right there with all the wires. We're already on this side. Run it along. This case is split in 2 pieces. What that means is we're gonna use the port already on this side, so I don't have to cross wires and do stupid stuff. Keep it simple, stupid. This way, the red one needs to go to your ground, well, your clamp. We'll just say clamp. Red to clamp. Which the clamp is positive on a plasma cutter. Oh, just so you know, these little screws I'm using in this board are off of a computer case, like what holds on a hard drive. Okay, one more time because I was using the wrong directions. This is a CNC. If your plasma cutter has the CNC connection or the serial ports, you can use this. This is what I was looking at when I hooked all this stuff up. Mine does not have that, so I was looking at the wrong directions because I was hooking up these direct arc connections, I believe is what they're called. On this, the red one goes to the clamp. The clamp on a plasma cutter is positive, so that makes sense. Black goes to the torch, which is negative. Make sure you test that. Use a multimeter continuity tester. Make sure your red goes to where you hook up your clamp. Because I noticed on here, embossed on here, red clamp, black torch, and the way that I had it hooked up was the opposite because I was looking at the directions for the wrong one. So take it apart, make it right. You never know who's going to be hooking this thing up. I could have left it alone and just plugged it in the wrong way, but you know, that's one mistake away from frying who knows what. Do it right. Often means you do it twice.
3, 4, 5, 6 times.
So this is what happens when you're editing all your videos and you realize either the battery died or you completely forgot to film a part. So this is a bit after. I'm in the plasma cutting trailer that's completely buried in snow right now. But I never showed how all this is wired to the system. So coming out of here, I've got the purple and orange wires. I kept the same color code that's inside here. These are the 2 wires that go to the torch handle that go on the switch. Connecting to the CNC controller, this cord goes to the torch on-off. So these 2 wires just trick this into thinking that you pulled the trigger on your torch. This red and black, this is for the THC controller. Remember, the red's hooked to clamp, black goes to torch. There's a circuit board in here it's all connected to. On here it's labeled clamp and torch, and then this cable goes on the PV output, and that goes to your THC connection. So I believe this box drops this signal down 50 to 1 so that the Langmuir system understands what it's saying. And that was that. The rest of it you hook up normally. Okay. Okay. Now I think if I hit this button, that'll cut.
Yes! Sweet!
Oh, it actually did. Oh, that is so cool. Yeah? Oh, that is awesome. Okay. Test 3, straight line. Everything works, which is really cool. Okay, so I got every part of this is working. The Hight controller works. X, Y, Z is obviously working because the Hight controller works. It cuts. The hacks into the plasma cutter work. Obviously the plasma cutter works. Program's working. It's communicating with everything. Everything works. I just need to, you know, get some real liquid in here and make up some actual programs. Yeah, so if you wonder why every time you see something being cut out on a plasma cutter, why it's so... They've always got some weird music playing on there, usually some kind of funky techno thing. It's because that's how loud it is when you cut something out, coupled with that thing spraying air. Okay, we're turning off dry run. I'm gonna hit go. This is the first test with something that I have programmed the G-codes myself, not just downloading something. So go, I guess. Very cool. Got a spider. Also makes you feel good. It's because there's a ton of money sitting here. And it's also the fact that a lot of things I buy are multi-purpose, like an air compressor. Yeah, it makes air, but you can run air tools, you run plasma cutters, you fill your tires, it's portable, like it has more uses. This thing, its only purpose is to do this. I know a welder just welds, but you make a lot of stuff with it. I know this cuts and you can make a lot of stuff with it, but it's not leaving where it is. And its versatility is, you're looking at it. It cuts stuff out two-dimensionally. Not saying that's bad. It's just, there's a lot of money sitting here. It makes you feel really good when you make it actually function and work the way it's supposed to.